Hi guys, I am super excited to get this YouTube channel up and running. I wanted to start with showing and modeling some division since that's the unit we're working on right now in class. The first one, I have a problem here, multi-digit whole number division, and I'm going to model solving this using our partial quotient strategy, which some of the kids know as the Super 7. They may also see this called the area model. There's a couple ways to do the area model, and this is the one that we've been practicing in class. So here's my model. The entire value of this is our dividend, 7,704. We need to repeatedly subtract groups of 24, that's our divisor, which we line up over here. Now, the next step I always tell the kids to do is to write out facts that they know. One super cool thing about this strategy is that they can use any multiplication facts that they feel comfortable with or confident in to help them solve this problem. They don't need to be using certain facts, which, especially if they're not as strong in this aspect, can be super helpful. So I always tell them to start with 1. 24 times 1 is 24. We have already had our lesson in class on the powers of 10, so if I know that 24 times 1 is 24, then I also know that 24 times 10 is 240. Because our place value system is base 10, I know that every time I multiply by a 10, our digits are moving left in the place value chart, which is why this extra 0 we have here, where it comes from. After this, they could even try 24 times 100. I know that that would be 2,400, which is even closer to my dividend. Now, their goal is to get as close to the dividend as possible. While they can use any number that they want, the more times they have to subtract in here, the more likely they are to make a mistake along the way. So I could use 24 times 100 because that gets me pretty close, but I know my two facts very easily. I can double 24. If 24 times 2 is 48, then I know that 24 times 200 is 4,800, and that gets me even closer. Now, this is where everybody will kind of veer off and do different things, and the beauty of this strategy, again, is that everyone's work might be different, but we will all end up at the same answer. They can use 200 as their partial quotient and subtract 4,800 from here and repeat that step as many times as necessary, or they can take time to continue multiplying, and some of them prefer to do this to see if they can get even closer. So I'm going to do that one more time. I'm going to see what 24 times 3 is. 4 times 3 is 12. 3 times 2 is 6, plus 1 more is 7. If I know that 24 times 3 is 72, then 24 times 300 is 7,200. Now, that is a much better partial quotient to use because it gets me very close to my dividend. So on this side of my model, and I kind of wrote this too close, first video, so the next one will be better. But I'm going to write 24 times 300 over here. This is the partial quotient that I'm using. I'm finding part of my quotient at a time. 24 times 300, we know, is 7,200, and I'm going to subtract that from my dividend. 4 minus 0 is 4, 0 minus 0 is 0, 7 minus 2 is 5, 7 minus 7 is nothing. Now my process repeats. I need to think to myself, what can I multiply by 24 that gets me really close to 504? Thankfully, I already have some work done over here, so I can see I could use 10. I could use 20, which would be 480. I skipped that over here, so I'm going to add it over here to the facts that I know. Because I knew that 24 times 2 is 48, 24 times 20 must be 480. I'm going to use that. I'm going to multiply 24 times 20, 20 groups of 24, which we know is 480. And I'm going to subtract that. 4 minus 0 is 4. I cannot take 8 from nothing, so I need to borrow from the next place. I'm taking 1 from this 5 and carrying that over here. This becomes 10. 10 minus 8 is 2. And what do you know? I can still take one group of 24 out of 24, and that brings me to 0. I always draw a smiley face here. I don't know why, but that's where they know they need to stop. Your goal is to continuously subtract until you get to 0 or until you can no longer take groups of your divisor out. If this number is larger than your divisor, then you know you're able to take at least one more group out, and they keep subtracting until they no longer can. So what we've done so far is we found parts of our product, we have found parts of our quotient. To find our actual answer, the actual quotient, we need to add these numbers together. I'm looking in my ones place, I have 0 plus 0 plus 1. In my tens place, I have 0 plus 2 is 2. In my hundreds place, I have 3 plus nothing. So when I add those together, I get 321. That is our quotient. This is one strategy we've been doing in class. I always encourage them to take the time to check their answer, which they know they can do by multiplying the answer you got, your quotient. If I multiply this by my divisor, I should end up with my dividend. Okay. This is, again, our partial quotients strategy, sometimes called the area model. There are two versions. This is one that they might see. Again, over here, everybody's answers might be different. They can pick anything they want to multiply by, but notice that really all I've done is 24 times 1, 24 times 2, and 24 times 3, and then I'm using my knowledge of the powers of 10 to get me closer to my dividend.